Hey everyone, and welcome. Today, we're going to pop the hood on your Linux system and really get into how it manages its own state. Everything from that first spark of power all the way to a clean, safe shutdown. It feels like magic, right? But it's not. There's this incredibly organized process running the show, a director that tells every other part of the system what to do and when. And today, we're going to pull back that curtain. So here's what we've got on tap. We'll start with the big boss, the init process. Then we'll take a look back at the classic sysv init system before jumping into the modern world of systemd. After that, we get hands-on with managing states and doing safe shutdowns, and then we'll wrap it all up. All right, let's kick things off right at the beginning. The moment the Linux kernel loads itself up, it does one thing. It hands over complete control to one single, very special process. This process is the foundation for absolutely everything else that's about to happen. And that process is called the init system. It always has process ID 1. It's the granddaddy of every other process running on your machine. Think of it like the conductor of an orchestra, making sure every instrument comes in at the right time to create the perfect operational state. Now, for a really long time, that conductor was a system called sysvinit. And it used a pretty simple but, effective concept to define what the system should be doing: numbered run levels. With sysvinit, it was all about these numbers. Each number meant something very specific. Run level 0, that means you're shutting down. Halt. Run level 6 is for rebooting. And the ones you'd use day to day were usually 3 for a command line server or 5 for a full-blown graphical desktop. So how did the system know which run level to boot into? Well, it was all written down right here in this file, etc/init tab. See that line? ID 3 init default? That one little instruction told the entire system, hey, every time you boot, I want you to go to run level 3. It was simple, for sure, but also pretty rigid. But, technology moves on. And today, pretty much every major Linux distribution has adopted a much more powerful and flexible system called systemd. And it takes these old ideas and really brings them into the modern era. So instead of those rigid numbered run levels, systemd uses these named targets. You can think of a target as a goal or a destination. It's basically a collection of all the services and resources that need to be running to reach that specific state. It's way more dynamic. And this chart just lays it out perfectly. The old concepts are still there, but the names are so much more descriptive and make a lot more sense. The old run level 5 is now just graphical.target, and maintenance mode, run level 1, is now called rescue.target. Same ideas, just a much cleaner way of doing things. And here's the real game changer. With sysvinit, you were either in run level 3 or 5. You couldn't be in both. But systemd targets can include each other. For example, graphical.target has everything that multi-user.target has, and then it just adds the graphical stuff on top. This, plus the fact that it starts things in parallel, makes systemd way faster and more efficient. Okay, enough theory. How do you actually drive this thing? Well, in the modern world, it all comes down to one incredibly powerful command: systemctl. And it's shockingly simple. Want to see what your system boots into by default? Just run systemcontrol get-default. Want to change it? Maybe you want to go from a graphical desktop to a command line server on boot? You just run set-default multi-user.target. Done. The next time you reboot, that's where you'll end up. But what if you need to change your system state right now without a reboot? That's what isolate is for. If you run systemctl isolate rescue target, it will immediately shut down all your normal services and drop you straight into single-user maintenance mode. It's an incredibly powerful way to switch gears on a live system. Now, when it comes to maintenance, you've got two main options. Rescue target is your go-to. It gets your file systems mounted, so you can get to work fixing things. But emergency target, well, that's the break glass in case of fire option. It barely mounts anything, and your main file system is read-only. This is for when things are so broken that even rescue mode can't start properly. And you'll definitely know when you're there. The system gives you this very stark welcome message. It's basically saying, okay, we're in serious trouble, but here's a command prompt. Good luck. It's your last best chance to fix a critically damaged system. All right, so we've covered starting up and changing states. Now let's talk about something just as important: the right way to shut down. And the classic shutdown command is still your absolute best friend here. I mean, it's so versatile. You can schedule a shutdown for 10 minutes from now. You can schedule a reboot and send a custom message to warn all the other users. And if you make a mistake, you can even cancel a pending shutdown. It's just the professional, courteous way to turn off a system. Of course, Systemd has its own direct, no-nonsense commands too. Systemctl power off and systemctl reboot do exactly what you think they do. And to be honest, a lot of the time, the old shutdown command is just calling these new commands under the hood anyway.
All right, we have covered a ton of ground here, all the way from old-school init scripts to modern systemd targets. Let's just boil it all down to the key takeaways.
So here's the bottom line. We've moved from this world of numbered, rigid run levels that were configured in a text file to a new world of descriptive, flexible targets that are managed with the super powerful systemctl command. The new way just gives us more control, more speed, and a whole lot more clarity. And understanding this stuff isn't just about passing a test or learning trivia. This is a fundamental skill. Knowing how to control your system state, for booting up, for doing maintenance, for shutting down safely, that's what separates a casual user from a real system administrator. You're officially in the driver's seat now. You can tell your system exactly how to behave, from the moment it wakes up to the moment it goes to sleep. So the only real question left is, what are you going to do with that power?